Right, another video on complex numbers. We're going to look at what we mean by the terms modulus and argument of a complex number. But first, we're going to look at something called Argan diagrams. To understand those, if we've got a complex number a plus bi, okay, in this form here, a is what we call the real part, and b is what we call the imaginary part. Alright, so now we draw a little graph, y plus x. So on a Cartesian coordinate system, when we're plotting a point, we plot the x coordinate and the y coordinate. When drawing an Argan diagram, we call this the real axes and this the imaginary axes, okay? So to draw a complex number, this is just a generic complex number. This is A and this is B, alright? And when we talk about the argument of B, well, it's the angle from the x-axis to the line. So if this is our complex number z, z's here, and this angle theta is the argument of z, okay. The rule is for arguments the convention, because if you think of this point, you could go around this way to it, you could go all the way around and then do this little bit again. You can get to this angle in many ways. So the convention is if there's a positive imaginary part, we come anti-clockwise from the positive x-axis, the positive real axis, and if there's a negative imaginary part, so it's down here somewhere, we come clockwise from the positive real axis, okay? So that's just something to remember when you see arguments. And the modulus is essentially the size of the complex number, like in many other things in math. So we draw down here and across here, and it's just Pythagoras' theorem. So this is length A, this is length B, so the modulus of z is equal to a squared plus b squared square rooted. Okay, now let's look at some examples. Let's take z1 is equal to 3 plus 2i. So the modulus of z1 is equal to the square root of 3 squared plus 2 squared, and that is equal to the square root of 9 plus 4, that's equal to the square root of 13. Okay, brilliant. Now for the argument of z, we're going to draw ourselves an axis. It just has to be rough, so I won't get the official lines on. Right, so z has real part 3, imaginary part 2, so we know this length is 2, this length is 3, and we want to know what this angle is, theta. So arg z is equal to theta, which is equal to, well, what we know is tan theta is equal to opposite over adjacent. It's equal to 2/3. Okay, so theta is equal to the inverse of tan of 2/3. Okay, so that's our argument. The other way we could, well, write this another way, we can write arg z is equal to arctan of 2/3. So hopefully you understand, or you're starting to understand, the concepts of modulus and argument, and you've been introduced to Argan diagrams, which we'll look at much more in the coming videos. The next video on complex numbers will be on adding them together, multiplying them and dividing them, so stay tuned for that. But for now, that's it for this video. If you've got any questions about complex numbers, please let me know in the comments down below. For now, please like, subscribe, and I hope to see